Okay, this is the P4 paper from January 2022. See the front cover there. Let's get started with it straight away. This is question number 1. So we can see this is differentiation question. I'm trying to find an equation of a tangent. Looking at this, I've got some products that I'm going to need to be able to differentiate, and it's implicit differentiation as well. So if we write out the question, xy squared equals x squared y plus 6, and if I'm trying to find the equation of a tangent, I'm going to need to find dy by dx. So if I call that u and I call that v, then what I'm going to be doing is using the fact that the integral of uv works out to be u dv by dx plus v du by dx. So that's the formula I'm going to be using. So for these implicit ones, we would expect you to do them quite quickly. If you want help just differentiating products, you're going to need to do that in a different video. So here, using this information, if I've got uv there, then I'm going to get that u dv by dx is going to be equal to x times the differential of y squared, and the differential of y squared is 2y dy by dx plus v du, which is going to give me y squared times the differential of x, which is going to be equal to 1. Okay, if I now do the same thing but for this one here being u and v, then I'm going to get v du by dx, sorry, u dv by dx is going to give me x squared times the differential of y, which is dy by dx, plus the differential v du, which is going to be y times by the differential of x squared, which is 2x. The 6 will disappear. Once I've got to that stage, then, depending on how much time you've got and how much you want to tidy these things up, I would always just write this a little bit tidier like that before I next look at my next step. My next step is to try and get dy by dx equals. So I need to get the dy by dx's on one side and everything else onto the other side. So here I'm going to say that this side is going to be my non-dy by dx side. So I'm just going to take the y squared over. This side is going to be the side where I'll keep my dy by dx's. So the whole point about doing that is so that I can do the next line, which is to factorize and take dy by dx out as a factor. Standard method, we do this an awful lot in other types of questions here. So now I'm going to get that dy by dx is equal to the 2xy minus y squared, all divided by 2xy minus x squared. Right, I can now I really read the rest of the question here. I'm trying to find the equation of a tangent. They've given me the point up there at 2, 3. So what that means is if I want to work out the equation of a tangent, I'm going to try and show my working out the way that I set things out here. Equation of a tangent, I would always use the formula y minus y1 equals mx minus x1. That's the equation of any straight line when I've got m, I've got x1, and I've got y1. So x1 and y1, yeah, I've got those straight away. They're 2 and 3. M is just going to be dy by dx at those values. So here, just explain what I'm doing. M equals dy by dx equals 2, lots of put the values in, so x is equal to 2, y is equal to 3, y is still equal to 3, over, again, x is equal to 2, y is equal to 3, x is equal to 2, So evaluate that. That comes out to be 3 over 8. And now I've got everything that I need. These three things. I'm just going to substitute in here for my x1, y1, and m. Let's do that. So I'm going to get y minus 3. Sorry, y minus 3 is equal to 3/8 of x minus 2. It's solved now, but I'll just take a little bit of time to do this. Multiply everything by 8, and we get rid of the fraction. So 8y minus 24 is equal to 3 lots of x minus 2. You can do this as quickly as you want this bit. 8y minus 24 equals 3x minus 6. Go back and look and see what the question said. ax plus by plus c equals 0. Okay, so I'll get them all onto one side. I like to have my x as being a positive value there. So my one works out to be equal to that. It would be exactly the same if you had the negative of all those values there. Okay, we don't have to have a positive x, we don't have to have a positive y. Right, hopefully that makes sense for question number 1.